Before we add in the code for the lasers, we're going to take a quick moment to talk about the general coding process. When it comes to programming, you usually start with an idea of something you want to create. Sometimes you're starting from scratch, and other times you're starting with existing code that you're trying to expand. Once you have that idea, the first thing you do is write some code. Typically, you code in multiple small incremental steps because it's easier to check just one or two things at a time. After typing up a chunk of code, you'll want to test it to see if it works. If it does, great. If your code does everything you want it to do, then you're done. But typically there's still more, and so then you go back to coding. This is the ideal pathway. However, many times the code just won't work. And if it doesn't work, then you need to go through the debugging process. This is basically just problem solving. You know what you want the code to do, and it's not doing it, so you need to figure out what's going wrong. There are three basic categories of problems. A syntax error is an error where you simply mistype something, and Python doesn't even understand what you're asking it to do. An example of this is if you misspell the name of a function. Then Python will give an error that basically says that it doesn't know what you're saying. A logic error is an error in your intellectual conception of the code. Beginning students often have trouble with this because the way they think the computer ought to behave is different from the way it actually behaves, and this comes down to not understanding the logic of the code. This is particularly true when it comes to if-then statements and loops. A runtime error is an error that arises when Python is running the code. This is basically any other error in the code that comes up while it's running. It could be a reference to a variable that doesn't exist, or maybe something like division by zero. People might argue about the specific categories here and what they mean, but none of that actually matters. The point is that the code isn't working and you need to figure out why. And once you understand that, you can go back and fix the code and try again. These videos are meant to be quick videos that give you an overview of how the code works, but we're not actually showing you all the steps of coding. The reason is that coding in real life is a slow and sometimes difficult process. A live coding version of this would be 3 or 4 times as long, and that's just too much time to spend on such a small program. But with that out of the way, we're ready to make our spaceship shoot lasers. The lasers are objects in our game, and so they're going to be sprites. But they are a sprite that's different from the spaceship, and so we'll need to build this into its own class. Basically, every new object we add from here on out will be its own sprite class. We can make the lasers into its own module, but since the lasers belong to the spaceship, it kind of makes sense to put it there. This is ultimately a decision based on the overall complexity of the laser. If the lasers were themselves going to be very complicated, it might make more sense for them to exist as their own module. Before we try to code this, let's think about what we want to have happen. We want to press the spacebar and shoot lasers from the front of the spaceship, but we don't want a constant stream of lasers. We want a small gap between them. Although this seems simple, it alerts us to several things that we're going to need in order to do this. We've added 2 variables to the spaceship class, the cooldown timer and the firing flag. The firing flag lets us know that the player is intending to fire. However, they won't be allowed to fire unless the cooldown timer is at 0. This allows us to control how fast the player can shoot. In the update method, we've added some code to get the cooldown timer to count down to 0. Now let's look at the main code. Notice that we can capture the spacebar being held down in the same place that we checked for the state of the left and right arrows. The firing code is run in the update portion of the code. Notice that this runs outside of the spaceship update method. The reason for this is that the laser is a new sprite, and it's easiest to handle the creation of sprites at the level of the main script rather than inside one of the modules. The first thing we need to do is check to see if the player is even allowed to fire. When they can, we then create a laser sprite. This sprite will be added to both the All Sprites group as well as a new Lasers group. We won't be doing anything with this group for now, but this will be handy later when we get to sprite interactions. The last piece of the firing code we need to look at is the shoot method. This is found inside the spaceship class, and it's just 3 short lines. It creates a laser sprite, sets the cooldown timer, and then sends the laser sprite back to the main code so it can be put into the sprite groups. The last thing we're going to need to investigate is the laser sprite class. All sprites need to have at least 2 methods, the init method and the update method. There may end up being more methods that we add in to make the sprite do what we want it to do, but these 2 will always be required. The initialization method will always start with the sprite initialization command. After that, we will always need to create the image and the rectangle for the sprite. Everything beyond that point will depend on what we want the sprite to do. We may need to position the sprite in a certain way, and we may need to create flags and other variables that the sprite is going to use. Here are the image steps for our laser. For the spaceship, we used an image that we had to load at the start of the module. Those images were loaded onto Pygame objects known as surfaces. But we can also just directly create a surface and color it in, which is what we've done here. Notice that we need to get the rectangle for this surface, just as we did with the images. The next part sets the sprite's position. We want the laser to start from the top middle of the spaceship. We're once again using the parts of the rectangle that we've talked about before. Notice that we can only do that if we have information about the spaceship, which is information we've passed along. Technically, we're actually sending along all the information about the spaceship, which is suboptimal, but it's good enough for this level of programming. Lastly, we're going to define a single parameter, and this will control the speed of the laser. For the update method, there are two things that need to happen. The first is that we're going to move the laser up based on the speed that we've defined. And the second thing is we're going to get rid of the sprite when it gets off the top of the screen. This step is really about not wasting memory by continuing to let the laser exist after it's out of the game field. Otherwise, the computer will be forced to keep tracking the location of the laser even when it doesn't matter, and that will ultimately cause the game to slow down. So this command takes care of that. And when we put this all together, we have our laser. If you wanted to change the laser from a solid color into an image, you could do that. You would first load the image into memory at the same time you load the spaceship image, and then you would just use the image as your surface. Now that we have our lasers, we need to start making things to shoot at. And the next couple videos will go through that process.